Hello and welcome back to Energy Center Live. I'm Chip McGuff, and with me as always is Jackie Stone. We all know a great defense wins championships, right, Jackie?
That's right, Chip. And successfully defending the living spaces of a home from the encroachment of outside or unconditioned air will make a home highly energy efficient with fewer pollutants and incredibly comfortable. Let's look at a typical home. These are the typical living spaces that are heated and cooled. And to keep unconditioned air from penetrating into those areas, we need to create a sealed, airtight thermal envelope around the perimeter. Think of it as the defensive front line of a home.
Now, there are several key plays to the air sealing game, and an option for how to win the game. Let's look at our game-winning strategy. It's important to remember that in order to create a great game plan, we must meet the mandatory rules of the game. First, for frame walls, cavity insulation must be enclosed on all sides by an air barrier such as drywall, OSB, plywood, or T-ply. This includes behind tubs, showers, fireplace units, and under stairs.
Second, there are 4 areas in a home where the largest leaks can occur. We call these the Big 4. They are blocking and sealing floor ceiling systems and under knee walls, capping and sealing shafts or chases, capping and sealing soffits or dropped ceilings, and sealing around HVAC supply and return boxes that penetrate the floor, wall, or ceiling finish. With these Big 4, we're essentially sealing up the floors, ceiling, and walls located within the thermal envelope.
In those Big 4, there are a lot of potential cracks in the defense, and we really need to double team them to seal them up tight. The best method for sealing these areas will vary. You might use caulk, expandable foam, mastic, tight-fitting blocking, fire-rated sealers, or other sealing products. Just use good judgment and be prepared to call an audible depending on the situation in front of you. With the mandatory rules covered, in other words, the large leaks sealed up, we can now focus on sealing the smaller leaks and picking our game-winning compliance option. For compliance option 1, the builder can choose the visual inspection. If this play is called, the builder must complete all the additional air sealing items identified in Table 402.4.2 in the code.
So let's get started by looking at those air sealing items from the bottom up to see where we need to shore up our defense and make option 1 a success. Hang on for the ride, team. There's a lot to cover for this option play. Now, air can get through where framing plates sit on the subfloor or concrete slab. Caulk the plate to the floor or use seal under the bottom plate. And don't forget about HVAC supply and return ducts located on the thermal envelope. Seal around the opening after the wallboard is installed.
Many utilities running throughout a home will penetrate the thermal barrier. That includes plumbing, electrical wiring, security wiring, HVAC vents, fire alarms, and other controls. Make sure those penetrations are airtight. Windows and doors are obvious points where air can enter in. The space between the window or the door jamb and the framing must be sealed.
Recessed lighting located in the thermal envelope must be ICAT rated, which stands for Insulation Contact Airtight. This means the fixture can touch the attic insulation, and the cans themselves are airtight. They must be sealed to the drywall using a factory-applied gasket or caulk.
The garage must be separated from the house with a sealed air barrier. Typically, this is done by blocking and sealing between the joist bays. In addition, be sure to install drywall or some other approved air barrier continuously around the garage ceiling and walls that adjoin conditioned spaces.
Floors, especially those above a garage, under a knee wall, or at a cantilever, should have an air barrier installed at the exposed edge of the insulation. Often, this is accomplished by installing blocking combined with sealant to stop airflow.
Remember that walls, ceilings, and floors may have access doors or hatches that must be properly insulated and weather stripped.
Finally, for the visual inspection option, let's talk about air sealing the connection in the attic between the top plate of the wall and the attic. These often missed critical spaces require sealants or a gasket to prevent air from washing down into framed wall cavities. Now, this can be eliminated in several ways. You can attach a gasket to the top plates of all walls that adjoin the attic. The drywall will seal to the gasket and prevent the cold attic air from falling down into the walls.
Instead of a gasket, use a sealant to adhere the wallboard to the top plate. This needs to be done when the wallboard is being installed to ensure the wallboard beds against the wet sealant before it cures. You can also seal the wallboard to the top plate connection from the top after the wallboard is installed and before the attic insulation goes in. If using this method, be sure to obtain a complete seal, including under attic flooring.
So, with all the sealing completed, the builder has successfully executed the visual inspection option play. Now, let's look at option 2. Arguably the best option for proving compliance is performance testing for air leakage using a blower door fan assembly. The fan paired with a manometer can accurately determine the level of tightness of a home's thermal envelope. With this test, there's no guesswork. The numbers speak for themselves.
And let me add, Jackie, all good coaches want to test their players in order to help them improve their performance. When we choose this option, we can measure our performance and get better.
Chip, let's remember our game plan before testing. The goal is to have a game-winning air sealing strategy. If all the air sealing measures we've talked about are implemented, this blower door test will be a home run.
When using the testing option, the tested air leakage must be less or equal to one of the two following performance measurements. Either 0.30 CFM50 divided by the square footage of surface area, or 5 air changes per hour.
The code details specific steps for setting up the home and provides a list of professionals qualified to perform the test. And be sure to record the chosen option and performance results on the Energy Efficiency Certificate. That's what you need to know about North Carolina code for air sealing a home and how to create a tight thermal envelope. We hope this information was useful and educational. The bottom line is that to create a comfortable home and keep those energy bills down, you must seal, seal, seal.
That's right, Jackie. And remember, if you have any questions or concerns, always refer to the most current North Carolina building code requirements or visit the NC Energy Efficiency Alliance website at ncenergystar.org. I'm Chip McGuff.
And I'm Jackie Stone. Thanks, and we'll see you next time on Energy Center Live.